So the next part of this hands-on activity is going to be a little tricky, and it may not work out perfectly on the one that I'm presenting to you right now because I did have to resize some of the squares um, because they came when I pasted them onto this document, they were huge, so I had to shrink all of them, and I'm not sure I shrank them all to the same size. But if you cut them out and you're doing this with me, it should work out nicely because yours should all be the same size. So what we're going to do with these squares that we have is we're going to put them into sets of three. Specifically, we're going to put them into sets of three squares together that would satisfy the Pythagorean theorem. So basically what I'm saying is when you connect three squares at the corners, you should be able to make a perfect right triangle um, in the space that's formed between the squares. So obviously we're going to have to rotate them. Um, so let me just show you this first example using some of the smaller squares. So I'm going to have to rotate them, and I'm going to move a few of them around. Uh-oh, I didn't realize it wasn't going to give me the areas here. Darn it. Okay, so I'm going to have to erase the numbers inside them, but that's okay. Oops. So what I mean is, let's start with, darn it, why is it doing that? Okay, let's start with some of these smaller ones here because those are easy to find the areas. So I'm going to start with this one that has an area of 9 and this one here that has an area of 16. And the reason I chose those two, I already knew because I had the areas written inside of them, I already knew that 9 plus 16 equals 25. And I knew that I had another right triangle that was a 5 by 5. So I'm going to take this right triangle, or not right triangle, excuse me. I'm going to take this square with the area of 25 and I'm going to rotate it and show you that these three squares should make a right triangle. And again, it's not perfect because I had to resize them, but it's pretty darn close. And you can see that we now have this right triangle inside those squares that is a 3 by 4 by 5. The hypotenuse is the 5, and the two legs are 3 and 4. And I know that that works, and I know that the Pythagorean theorem works with this example because, hold on, let me switch to the pen real quick. Sorry. Because one side is 3, and I know that 3 squared is 9. This one's 4, so 4 squared is 16, and this last one is 5. So the Pythagorean theorem works. 3 squared plus 4 squared equals 5 squared. So that's one set of triangles. I mean squares, excuse me, I keep saying triangles. That is one set of 3 squares that form a right triangle on the inside. So now I want you to try to find another set of triangle or squares that will form a right triangle in the middle. And if it helps, you can use the areas that you already have written inside and see if you can find the areas of two smaller triangles that'll add up to the area of some of the bigger ones. I keep saying triangle, but I'm saying area of a square. So I can see right away, I'm just looking at some of these squares here, and that one's 25, even though I erased it. But I'm looking at some of the squares here, and I can already see two numbers that will add together to give me a third one. So look at this one here. If I take, it keeps taking me to the wrong screen. If I take this one here, 36, and I add 64 to that, I already know in my head that 36 plus 64 equals 100. Right here. So what I'm going to do now is I'm going to take those three squares and put them together and see if they will form a right angle. And remember, with a right triangle, which technically has a right angle. But remember, when you have a right triangle, the hypotenuse is always going to be the longest side. So if this one works, this larger triangle that has an area of 100 should have the hypotenuse with a length of 10. So let me erase the inside numbers here, and then let's put them together and see if it works. And I'm going to go ahead and erase this 81 because I'm going to have to move it. Okay, so I've got my triangle. Let me move that one. I've got this one here that has, it's a 6 by 6. I'm going to move this one out of the way because it's kind of in the way here. Okay, so I've got this one that's a 6 by 6, which is an area of 36. And I've got this one here that's an 8 by 8, so that's an area of 64. And I think, according to Pythagorean theorem, which we're proving right now with this little activity, this square that's a 10 by 10 should fit perfectly as the hypotenuse of that right triangle. Let's give it a try. If I rotate it here. I said perfectly, but there's no way to do this perfectly when you're resizing the squares. But you can see that I'm getting pretty darn close, and it works. So that one worked. So that was a right triangle that has a leg with a 6 right here, a leg with an 8 here, and a hypotenuse with a length of 10. And there's my right angle. Okay, so we've now done 2 sets of 3 squares that formed right triangles. Let's look at some of the bigger ones now. I already erased, hold on. I already erased this one, but this one was another one that had an area of 25. I also erased this one, which is has an area of 81. So look at the squares that you have left and see if you can find some sums that will add up. So I'm just looking here. I've got 144, I've got 81, I've got 25, 169, and 225. I'm thinking if I add the 144 and the 81, that might give me something. So I'm just going to grab my calculator really quickly, and I'm going to add, where is it? Okay, so I'm going to add 144 plus 81 and just see what I get. Aha! If I add 144 and 81, I get 225, and I believe I had one down here. There it is. I had a larger square with an area of 225. So let me do a little manipulating, and you do the same thing with your actual squares. I'm going to erase this one and move it out of the way because it's in my way right now. And I'm going to erase the large one. That's the 15 by 15 that had an area of 225. And this one here was the one that had, well, let me go ahead and move this one as well. Okay, so this one that I'm erasing right now is a 12 by 12. The one that I'm going to move to make a right angle with is a 9 by 9. Just going to label those so you remember. So that was a 12-sided leg, and that's a 9-sided leg. There's the right angle of my right triangle. And the last thing I'm going to do is take that large square, that's a 15 by 15, and I'm going to try to rotate it to see if it will fit and make a right angle. right here, or a hypotenuse, I should say. Not perfect, but again, it's pretty darn close. Hopefully yours turned out a little better than mine. Voila. Okay. So now I only have 3 left. So I'm betting that those 3 will be my last 3 that form, that when put together, they make a right triangle and they prove that the Pythagorean theorem is correct. So let me move them down. Well, let me erase that. Okay, so the biggest one is a 13 by 13. Okay. And then this one here is a 12 by 12. I'm just trying to move them all down. And this one's a 5 by 5. All right. So if this works, remember the longest side is always the hypotenuse. So this would be the 12 right here. This would be the 5. I'm going to go ahead and label those really quickly just so you remember. That's the 12-sided leg. That's the 5-sided leg. And this last one is a 13 by 13. So we are now going to use this one to form the right triangle. Oh yeah, I forgot that it doesn't stay. Voila, look at that. It made a right triangle. So what we've done is we have just basically proved that the Pythagorean theorem works, and it works. It only works on right triangles though. So let's write a concluding statement just to kind of sum up this activity. I'm going to put in a text box here. So what we have just done is we've proven that in a right triangle, the sum of the squares of the 2 smaller sides always equal the square of the longest side, or the hypotenuse. I hope that this activity helped and didn't make things more confusing, but I just wanted to make sure that you've seen why and how it works, and why, why is it that we're squaring the numbers? Why are we taking the legs and the hypotenuse and raising them to the second power? And you can see that right here, it literally means that we're using squares.